Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. This is the last part of this video section, that is the types of instrumental methods. Already we have covered initial instrumental methods in 3 different videos. If you have not watched my previous videos, to get the better understanding, you can watch my previous videos also. In this video, we will be discussing the remaining different analytical spectroscopy techniques as well as different miscellaneous methods used in the instrumental analysis. Now let's begin with our today's session. Before that, just we will see what are the learning outcomes of this session. After watching this my video, students will be able to explain different types of instrumental methods. Now, in previous videos, we have covered different spectroscopy techniques like the IR spectroscopy, ultraviolet spectroscopy, atomic absorption spectroscopy, mass spectroscopy, Raman spectroscopy, as well as the NMR spectroscopy. Now, next analytical spectroscopy technique that we are going to discuss is about the fluorimetry as well as the phosphorimetry. Fluorimetry and phosphorimetry is the determination of fluorescence and the phosphorescence. Now, actually, what is the meaning of fluorescence and phosphorescence? When a beam of light is passed through a sample, it will absorb a certain amount of energy, and again whatever the amount of energy that is absorbed, that molecule will, or atoms that are present in the molecule, will go to the excited state, and while coming to the ground state they will emit the certain amount of that energy in the form of the photons, and this photon, these are known as the determination of fluorescence as well as the phosphorescence. In fluorescence is the re-emission of the longer wavelength, that is the low frequency photons, by a molecule that has absorbed photons of the shorter wavelength. Absorption and emission of energy are characteristics of a molecule during the fluorescence process. Light is absorbed by the molecules for a very short period of time, which causes electron to become excited, and they will shift to the higher electronic state. And all of this excess amount of energy is not lost by the collision with other molecules, and the electrons return to the ground state, and the energy that is emitted during the return of the electron to the ground state, and that energy is eliminated in the form of the photons. And the emission of light is an instantaneous process, means it's very quickly and start immediately after the absorption of light and stop as soon as the incident light is cut off. So this is known as the fluorescence. Then next technique is phosphorescence. Here phosphorescence is also a re-emission of the longer wavelength. When a beam of light is incident on certain substances, they emit the lights continuously even after the incident light is cut off. So this is the basic difference between the phosphorescence and fluorescence. In fluorescence, the emission of light will stop as soon as we cut off the light, but in phosphorescence, the light will be continuously emitted when the incident light is cut off. Emitted light is always having a longer wavelength than the absorbed light due to limited energy loss by the molecule prior to the emission. Now, next technique that we are going to discuss is Nephelometry as well as the Turbidimetry. Turbidimetry is an expression of optical property of a medium, a cuvette containing suspended particles, which causes light to be scattered and absorbed rather than the transmitted in straight line through the medium. Already I have told you what is the meaning of light scattering. So this Nephelometry and Turbidimetry, they are based upon the light scattering effect, where nephelometry is involved in the measurement of scattered light. The components of nephelometry are the same as the light spectrophotometer, except that the detector is placed at the specific angle, that is the 90 degree from the incident light. Detectors may be placed at, here you can consider it as a 90 degree, 70 degree or a 37 degree depending upon the angle at which most scattered lights are formed. Then next technique that we are going to discuss is turbidimetry. Turbidimetry is concerned with measuring the amount of transmitted light, where in nephelometry we have seen that it is involved in the measurement of scattered light, while here turbidimetry is based upon the measurement of transmitted light, and the calculation of the absorbed light is carried out by particles in suspension to determine the concentration of the substance. Basically, both these techniques are used for the suspension. Suspension means what? If we take mud and if we add into the water, then whatever the water is there, it will become cloudy. So these mud particles will be suspended, they will not be dissolved in the water. That type of the content is known as the suspension. So these techniques are useful for the determination of the concentration of the suspended particles in the suspension. The amount of scattered light depends on the size and number of particles in the suspension. Since the amount of scattered light is far greater than the transmitted light in the turbid suspension, nephelometry offers a higher sensitivity as compared to the turbidimetry. Means if we compare between these two techniques, nephelometry is considered as a more sensitive as compared to the turbidimetry. Then last analytical spectroscopy technique that we are going to discuss is flame photometry. It is rather an emission spectroscopy, where the flame photometry is a process wherein emission of radiation by a neutral atom is measured. The neutral atoms are obtained by introduction of sample into the flame. Hence, the name is given as flame photometry. It is generally used for the analysis of metals or inorganic substances like sodium, chlorine, then potassium. Since the radiation is emitted, it is also known as the flame emission spectroscopy. So here we have finished with the different analytical spectroscopy techniques. So 10 different techniques that already we have seen. Now there are few miscellaneous methods are there, which are generally based upon the determination of, based upon the thermal method or the different optical properties of that particular molecule, like refractive index, radioactivity. So first miscellaneous technique that we are going to discuss is thermal gravimetric analysis, which is also known as the thermogravimetry or TG. Thermal gravimetric analysis uses stoichiometry as well as the heat ratios to determine the percentage of mass of a solute. So they are based upon the determination of the mass of a solute. In this technique, sample is continuously heated at different temperatures, and the changes in that particular sample are observed throughout this particular heating. This is known as the thermal gravimetric analysis. Test and analysis is carried out by gradually increasing the temperature of a sample and plotting a graph between temperature against the weight. So effectively monitors the material transformation where compounds degrade to form a different temperatures. Then next miscellaneous method that we are going to discuss is the differential scanning calorimetry, which is also known as the DSC. This is also one of the important technique. This is also thermoanalytical technique that is used to demonstrate the energy phenomena that is produced during the heating or cooling of the substance, and to determine the changes in the enthalpy as well as the temperature at which this occur. DSC instrument measures the heat flow in and out of both a sample and a reference crucible during a controlled temperature program. The sample crucible usually contains a substance under study, and the reference crucible is either left empty or is loaded with the inert reference material relevant to the sample under investigation. So this is about the differential scanning calorimetry. Next method that we are going to discuss is refractometry, which is based upon the measurement of refractive index in order to access their composition as well as the purity. We know what is the meaning of refractive index. The speed of light in a vacuum is always same, but when light moves through any other medium, it travels more slowly since it is continuously being absorbed and re-emitted by the atoms in the material. The refractive index of a medium is measure of how much the speed of light is reduced inside the medium related to the speed of light in the vacuum. A refractometer is an instrument used to measure the refractive index of that particular sample. So refractometry gives us information about the purity of that particular sample. Then next technique that we are going to discuss is radioactivity. This is also one of the important technique which is useful for the determination of radioactive samples. Radioactivity methods involves the measurement of intensity of radiation from a naturally radioactive material and are used in determination of trace elements, in examining geological specimens, in quality control of the semiconductor manufacturing. Also, for a different diagnostic purpose, also these radioactivity techniques are generally utilized. For example, in angiography, we know it is used for the determination of function or the blockage of the different heart blood vessels. So for that purpose, radioactive material is inserted as a dye and the different pictures of or the photographs are taken and the blockage of that particular or the clotting factors that are generally observed. Radioactive is a process in which unstable atomic nuclei loses energy by emitting radiation in the form of the particles or the electromagnetic waves. These radiations are capable to ionize the atoms and the molecules along their track. As these radiations are able to cause cancer and the death, it concerns with the healthy as well as the safety. Then last miscellaneous method that we are going to discuss is kinetic methods. Kinetic methods involves the study of increasing the speed of reaction by adding small amount of catalyst to the reaction mixture. These methods are found to be useful in determining the submicrogram amount of appropriate organic substance, in determining the amount of substance in the solution, and in the clinical chemistry. So these are the various miscellaneous methods that are used for the analysis of different samples. Now, which analytical method that we are going to use for the analysis of particular sample? It depends upon its different properties or what information we wanted. So there are various factors which are used for the selection of analytical methods that we will see. In order to select an analytical method, it is essential to understand clearly the nature of analytical problem. Means we have to first identify what is the analytical problem. Means whether we have to identify concentration, whether we want to know the structure of that molecule. So what is the actual analytical problem that we have to see. Now some of the following points should be considered for selecting any analytical method for the qualitative as well as the quantitative measurement. First thing, available sample amount, means whether you are having sample in the minute quantity or major quantities. Then physical chemical properties of the sample, whether it is a solid, liquid, melting point, all these factors are to be considered. Then interference in the sample, speed, ease and skill, and the cost of the analysis. Then number of samples to be analyzed. Then accuracy and precision that is required for your analysis. And last factor is concentration range of the analyte. So these are the various criteria that are used for the selection of analytical method. Thank you.